Okay, perfect. All right, guys. So yes, I think we are done with the section 2.1. We covered the frequency tables, histograms, ogives. Yeah, I think we are done actually with the section 2.1. There is one exercise, from Monday. Um, um, I don't think I have time actually to go over the exercise because it's gonna take at least 30 minutes, 45 minutes. But of course, if you have any specific question about the exercise, you can email me, all right? So yeah, my plan today is to start a new section, to move to the next section. And yes, and again, guys, please, if you have problems with the exercise or the homework or the exercise in the lecture, email me anytime. All right, so let's start section 3.1. So this is about measures of central tendency. So the goal of this section is to compute the average. You have you have your data values, you have your data, and the goal is to compute the average of your data. And actually, there are it turns out that there are different ways to compute the average of the data. Okay, but what's the average? So what do I mean by average? Average of the data values. It's a number, right? It's a number. It's one number, and it's actually used to describe your data or your sample data. Okay, and yeah. So the goal. So the goal of this section is to to compute the average of our data values. Okay, and so what do I mean by average again? So the average is just a number. It's a number, and that number is supposed to represent or describe the entire your entire population or sample. So the average is, it's a number. It's one number. Is one number. One number used to describe the entire population or sample. Okay. And yes, so as I said, there are different ways to compute the average. So we're gonna discuss first we're gonna discuss like 3 different ways to compute the average of data values. So there are different ways to compute the average of data values. So first, we're gonna start with so we're gonna study like 3 different ways to compute the average. So first, we're gonna start with the mode. Okay. So we're gonna study like 3 ways to compute the average. Okay, so first, so we're gonna have the mode, okay, and then we're gonna have the median, and then we're gonna have the mean. Okay. All right. So first, let's start with the mode. Okay. So what's the mode of, so first, so let's start with the mode. Okay. And the mode of the data set is just the value that occurs the most frequently. Okay, so the mode of a data set is, it's just the value, or the data value is the data value that occurs the most frequently. So, for example, so let's say we have the following data values. So we have the following data values. Okay. For example, let's say you have like 3, 4, 10, and then 2, 4, 4, for example, 1, 5, and then 9, and then 9. Okay, so it's like you have like so we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 data values, right? So the question is, yeah, so I want to find the mode, right? The mode. And so what we are saying is the mode is just the data value, or the number that occurs most frequently, okay? So for example, if you take 3, I'm going to just take 3, right? If you take 3, well, 3 is, well, we have only one 3, right? It's just one time, right? It's just one time, right? Now, if you take 4, so how many 4s do we have? Let's see. So there's 1 4, 2 4s, 3, right? 3 4s. Then for 10, it's only 110, right? There's only 110, 1 2, you know, 1 1, 1 5, but then you have like two 9s, right? So then the mode would be, right, the data value that occurs.
4 would be mode.
4. Yeah, it would be 4, right? Because so the answer here would be 4. Okay, because well, we have, so 4 occurred like 3 times. Okay, so 4 is repeated like 3 times, right? So that's our mode. I mean, I think it's not really hard. So this mode, you need to count, you know, for each data value, you count how many times you have that data value, right? And yeah, then the mode, of course, would be the data.
The
data
most
value.
frequently,
Yeah,
yeah.
the most frequently, yeah. Okay, so that's for the mode. Now let's move to the median. I think the mode, it's kind of clear, unless of course you have any question, guys. For 2, the median. Okay, now median, it's not as easy as the mode. Okay, I would say. So what's the median? Well, the median, that's the data value, or the number. It's actually so the median is the central. The median is the central. Okay, central value of an ordered. So here the key word is ordered data set, or data values. So when I say the central value, I mean like the value which is like in the middle, like in the center of your data values, right? But the thing is, you need first you need to order your data values, right? That is this word order, right? So first you need to order your data values, and then you need to find like the center, the center of value, or the value in the middle or in the center of your data set. So for example, so there are actually two steps. So for example, it's an example here. So let's say we have the following. Data values. Okay. So let's say we have 2, 3, 11, 3, 4, 6, 9, 3, 1, and then let's say 1. Okay. So we have like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 data values, right? And I want to find the median. So what's the median here, right? So first step, you need to order your data values, right? From the smallest to the largest data value. So first step 1, we need to order. We need to order our data values from the smallest to the largest. From the smallest to the largest. All right. So we're gonna start with the smallest number. So the smallest number, as you can see, it's 1, right? There is 1 here, right? There is 1 here. So we have 2 ones, right? So we need to start with 1, right? So it's first we have 1, and then there is another 1. It's not just 1, right? It's 2 ones. And after that, after 1, there is 2, right? There's as you can see here, there is 2, only 1, 2, right? So I have 1, 2. Threes. How many threes? I have like 1, 3 threes, right? So it's like 3, 3, and another 3. And then there is 4. And then there is 6. Then there is 9. And then there is 11. Okay. So I ordered my data values from the smallest to the largest, right? And as you can see, guys, I mean, if you have like I have a data value, I mean, repeated like 2 times or 3 times, etc. Like 1 here, we have 2 ones, right? So you have to write down both of them. Okay, the 2 ones. Okay. All right. So that's the first step. Now, next step, you need to find like the middle. So the middle, the center. Okay, the center of your data your data set would be the median. So step 2. So we need to find like the center or the middle of the middle of the data set or the data values. Okay. So in other words, which number is like in the middle of your data set, right?
3.
Yes. So the thing is, so we have how many numbers? We have like, so we have like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. So we have 10 numbers. Then the middle would be, so 10. We have 10 numbers. Yes. It's not exactly 3. Just 1 second. You will see. it's actually between 3 and 3. It's not the middle. It's not like 3. The middle is like it's like here between between 3 and 3. You have like 5 numbers to the left and there are like 5 numbers to the right. Okay, so the middle it's actually it's not
3 and 3, yeah.
yeah 3 and 3, right? Well, here it's just a coincidence you have like the same number, but the question is, so what do we do if like we have like 2 different numbers, like 3 and 4, in the middle? Then in that case you need to take the average. But anyway, so there are like 2 cases here. So we have like I'm gonna just give you a formula. You can use it to find the middle. So we have there are like 2 cases. So if you have an even number of data values, like here we have 10 numbers, right? So 10 is even. So if you have even number, so if we have even numbers, or even number of data values, okay, so like here in this example, we have 10. We have 10 numbers, and that's even, right? 10 is even. Okay, so if you have even number, so what you do is you're gonna add, so the middle, so then the middle would be like the number of data values, the number of data values plus 1 over 2. That's 1. And then you divide the whole thing by, like in this case, like in our case, we have 10 numbers. So then the middle would be like 10 plus 1, like 10 plus 1 over 2. So that's like 11 over 2, and that's 5.5. So what we are saying is like 5.5, it's between 5 and 6. So then the middle, it's between the 5th and the 6th data values. Okay, so 5.5 is between 5 and 6. So then the median, so the middle is between the 5th and the 6th number. The 5th and the 6th number. So like here, in our case, the 5th and the 6th data values would be like, so it's like, so this is the first number, 2nd, 3rd, 4th, 5th. So this 3 here, that's my 5th number. And then the next 3, that's my 6th number, right? So the middle would be, between, as I said, between the 2 numbers, between the 5th and the 6th numbers. So then the answer, your median should be the average of these 2 numbers. So then the answer, so then the median would be the average of the 2 numbers, right? So it's the average. So it's the 5th number plus the 6th number. So that's 3 plus 3. So it's 3 plus 3, and then you need to take the average. Okay, so this 3 here, that's my 5th number, and this 3 here, that's my 6th number. Okay. And then we divide by 2. So it's 6 over 2, so my median is 3. And as I said, in this example, just we are kind of lucky that my fifth and my sixth number are they're the same, right? They're both equal to 3. But like if you have like two different numbers, then for example, let's say you have like 3 and 5, then that would be like 3 plus 5 over 2, right? That would be 8 over 2. That would be 4. So you take your we have 10 numbers. You take the fifth, this plus the sixth over 2. But this is when you have even number. So because when we have even number of data values, the middle would be like between two numbers. Now, if you have like odd number of data values, okay, then the middle would be exactly one number, okay? So if we have, so I'm gonna do another different example where we have like odd number of data values. So if we have like odd number of data values, okay, then the middle will be exactly, well, it's again, the middle would be the number of data values plus of data values plus 1 over 2. Okay, but this time the middle would be exactly just one number. Okay, it's not the between two numbers. It's going to be exactly one number. So for example, let's take a very simple example. Let's just have like 3 numbers. Okay, for example, let's say 4, 5, and 2. Okay, so here we have 3 numbers, right? We have 3 numbers, and as you can see, the middle would be 5, right? It's clear the middle would be 5. It's not like between 5 and 2 or between 4 and 5. The middle is exactly 5. Okay. So when you have like a odd number of data values, the middle is going to be exactly one number. So we have three numbers. So the middle, like here, the middle is just 5.
I have a question.
Mm-hmm.
Okay,
yes.
I thought we had to put it in order.
Yeah, we have to put it in order to find the median. I didn't find the median yet. So here, like here, to find the median, yes, you're absolutely right. So if you want to compute the middle for this example, I would order the numbers first. So that will be like 2, 4, 5, right? And so the answer median would be 4, right? The number in the middle. You're absolutely right. Here, I'm just saying, like, if you have like odd number of data values, then the middle would be, it's not between the two numbers. It's going to be exactly given by one number, right?
Oh, that confused me. Okay.
Yeah, yeah. But yeah, so the middle here would be the number between 2 and, would be the 4, of course. Yes.
So even for your example, how you put 4, 5, 2, if they had it in this format, the 4, 5, 2, we still would have to put it in the 2, 4, 5 way, correct?
Yes.
To find out?
Yes, yes. So yeah, you have the 4, 5, 2 first. So to find the median first, you need to order order your data values. That's always like the first step. Yes.
Okay.
Yeah. That's always the first step. But the thing is, what's confusing is what will be the middle, right? And the middle is not always like a number. It can be like between two numbers. You know, it depends on how many. If you have like even or odd number of data values, you see my point? Like, if you have just two numbers, right? I have like 1 and 4. What's the middle of two numbers? Well, it's gonna be, it's not exactly one number. It's middle between two numbers. But what I'm saying is, like, you have like 3 numbers, right? Then the middle, it's clear it's going to be the 5. It's not like between two numbers, right? it's the 5. So we have like two different situations, right? This is when we have like, this is like when we have like even, like you have even number of data values. Here I have two numbers, right?
Right.
And here, this is like when we have like odd number of data values. I have three numbers, right? That's odd number of data values. And the middle, it's different, right? Here, it would be like in the center between these two numbers, the 1 and 4. But for 5, 4, 5, 2, the middle, it's exactly 5.
That's exactly where whatever number's in the middle. Okay, so then going back up to where you said the middle equals the number of datas plus the 1, you'll be making the number even then.
Yes. So here, like this, absolutely. So this is like, so for 5, 4, 5, 2, we have 3 numbers, right? Plus 1 over 2, that'll be 4 over 2. So the middle, it's actually the second number. That's what we are saying here. So the second number, of course, that would be 5. The middle would be the second number. So if you have like 3 numbers, you have, so what I'm saying is here we have, so here we have 3 numbers, right? 4, 5, 2, we have 3 numbers. And the middle, we said it's number of data values. I have 3 numbers plus 1, make it even over 2. So 4 over 2, that would be 2. So what we are saying is the middle is going to be the second number. In my example, previous example, you know, when I have like 10 numbers, my middle, 10 plus 1 over 2, 11 over 2, that's 5.5. So that's not a whole number, 5.5. It's between 5 and 6. And so what we are saying is that the middle would be like between the 5th and the 6th numbers.
Okay, so these numbers, the 5.5 and the 2 only represents the place value of the data.
Yeah,
okay,
that's
all right, perfect. All right.
That's what I mean by the middle.
Okay.
Yeah, that's like the position, right? That's not it's not the answer.
Okay, that's what I was confused about.
Yeah.
Okay.
Yeah. That's what I mean. The middle, that's like the position of the center, you know, the position of the center. Yep. Probably just erase this here. Yeah. All right. So let me do one more example because I know kind of confusing. So I'm gonna just do one more example. Example number 2, and this time I'm gonna take odd number of data values. Let's say we have 4, 5, 6, 7, 4, 6 again, and then 5, 1, 2, 3, 4, 5, 6, 7, and let's take 11 and 8, right? So like in this case, we have how many numbers? We have 1, 2, 3, 4, 5, 6, 7, 8, 9, right? So we have 9 numbers. Okay. And so let's find the median. So 9, of course, that's odd, right? 9 is odd. Anyway, so let's find the median. So first, always, you need to order your data values. So step 1, let's order the numbers. Start from the smallest. The smallest, of course, would be, just erase this. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Yes. So the smallest would be 4. How many 4s? So we have 4, 2 4s. So that'll be 4, 4. Then 5, we have 2 5s. 6, 2 6. 7, and then there's 8, and then there's 11, right? So I ordered my data values. Step 2, I need to find the middle, right? And you know, guys, this is like a very this is like a data with you know, the size of the data here is very small. Like we have 9 numbers, right? But imagine you have like 100 numbers, right?
Would 6 be the middle number?
Yes. Yeah. So step 2, Yes. So the find the middle. And what I'm saying is to find the middle, you can just take the number of data values. I have 9 numbers. So 9 plus 1 over 2. So that's 10 over 2. That will be 5. So my median would be the 5th number. So median is the 5th. It's the 5th data value. So 1, 2, 3, 4. So here's my 5th data value. So the answer median would be a 6. Okay. Now, all I'm saying, it's like, well, here we have like data with the size of the data here is very small, right? We have like 9 numbers, but imagine you have like 99 numbers, right? That will be very difficult to, to find, the center by just by hand, right? So it's actually this formula to compute the middle is kind of useful. So if you have like a data with a large size, right, and you want to find the middle, you can always use this formula of the middle, right? And it's always, the number of data values plus 1 over 2. Any questions so far, guys? So first step, you order your data values. Second step, compute the middle. That's the number of data values plus 1 over 2. And your median would be like, well, again, the answer, you see here, the answer, it's a whole number. It's 5. That's my, so the 5th data value, that's my median. But like in my previous example, because I have like, I have 10 data values. I have even number of data values. But the answer was the middle was like 5.5, which means that the middle is actually between the 5th and the 6th. So I need to take the average of the 5th and the 6th data values. All right. So that's for the median, and then the third way to compute the average, there is the mean, of course. So 3. So we have the mode, we have the median, and then we have the mean. Okay. So for the mean, it's the mean is it's just very simple. The mean, it's always the sum of all. The mean, it's actually the sum of all data values divided by the size of the sample, or total number of values. Total number of values. Okay. So the total number of values, this is just the size, that's the size of the sample. Okay. So for example, so let's say we have the following. Data values. Okay, so let's say you have like 4, 3, 5, 3, and then let's say 4 again. Okay, and you want to compute the mean, right? So what I'm saying is the mean would be the sum of all data values. So that would be like 4 plus 3 plus 5 plus 3 plus 4 again, right? So the sum of all data values, and then you divide by the whole thing divided by
19 divided by 5?
By 5, right? Because I have 5 numbers, that's the size of my sample, so we need to divide by 5. So that will be equal to, so first, guys, you need to start with the top, right? The numerator, the top. So we have like 4 plus 3 plus 5 plus 3 plus 4, etc. Right? So it's a 4 plus 3, that's 7 plus 5, 12. 12 plus 3, that's 15 plus 4, that's 19 over 5. Okay, and then of course 19 over 5, that will be equal to 3.8, I think, right? So this is 3.8. So the answer is 3.8. So again, the 5, that's because we have 5 numbers, right? This is because we have 5 data values. Okay. Let me just fix some notation, guys, because we're gonna use this notation. The mean, of course, we're gonna use the mean later. In the next, it's gonna be very important, notion, like in the next chapters. So just to fix some notation for the mean. So if you have, well, there are 2 cases, right? There is the sample data. So if you have a sample data, so there are like 2 cases. I mean, most of the time we have like a sample data. So if you have a sample data, then the mean is denoted by X bar. So you have sample data. So the mean is denoted by X bar. And if you have a population data, I mean, data from all your population, which is not really frequent. So if you have population data, then the mean is population data, right? Then the mean is denoted by a Greek letter. It's denoted by mu. So this is like, so we have like, it's like U. It looks like U, but it's not, okay? So this letter here, it's called the mu, mu, mu. Okay. So if you see X bar, or if you see this mu, this is, again, this is Greek. Oh, this is Greek letter. Okay. Then that's the mean. Also, the size of the sample, usually we denote the size of the sample by the size of the sample. So if you have a sample data, so we have so if you have a sample data, then the size of the sample, it's denoted by lowercase n. Okay, it's n lowercase. So again, what I mean by the size of the sample, that's the number of data values, how many numbers we have, right? So again, this is just the numbers, the number of data values, a number of data values. So the number of data values is denoted by lowercase n. If you have a population data, okay, then the size of the population is denoted by capital N. Okay, so if you have a population data, then the size of the population is denoted by capital N. Okay. Now, so we have the X bar, we have the N, the size of the sample. Now, the sum, there is a notation for the sum. So if you have a sum, the sum is, like in the mean, we are supposed to take the sum of all data values, right? This is, here it's a 4 plus 3 plus 5 plus 3 plus 4, etc. Right? So there is a notation for the sum, and it's actually denoted by. So the sum is denoted by capital sigma. So this is called this is capital sigma. This is of course a Greek letter, so it's called, this is capital sigma. It's capital sigma, and as I said, it's Greek. So if you see this symbol, the symbol means the sum. Okay. So we have notation for the mean. It's x bar or mu. The size of the sample is also always denoted by n. This is a sum is denoted by this capital sigma. Then last notation is how do we denote the data values, right? Like here in the mean, you take the sum of all data values, the 4 plus 3 plus 5, etc. So the data value, a data value is denoted by the variable x. So data value is actually denoted by x, the variable x, just x. So for example, let's say we have the following data values. We have the following data. Okay, so let's say again, it's 3, 4, 5, and 4. And let's say also 2. Okay. Yes. Yes. Any question for me? Okay. Yeah, so let's say we have the following example, right? 3, 4, 5, 4, 2. This is a sample data, right? It's not, doesn't represent, let's say, doesn't represent the whole population. This is just a sample data, right? This is sample. This is a sample data. Okay. So what would be x in this case? So what do I mean by the variable x here? What's x in this case? Well, as I said, the data value is denoted by x. So when I say x in this case, I mean
It would be 5.
Actually, no. X can be 3 or 4 or 5 or again 4 or 2. Okay. So x is like x is your data value. So it can be 3, 4, or 5 or 2. So x. So when we say x, so x can be can be 3, or it can be 4 or 5 or 2. Okay. So x is like the value of your, the data value. So here the data value is 3, right? So that would be like your first possible x. Second possible x is 4. X can be equal to 4. X can be equal to 5. Okay, etc. So I mean, each number in your data.
Wait, I'm sorry. How can x be all of these numbers?
So because the x is supposed to be a variable, so then a variable means like it can take like different values. Okay, it doesn't have like just one value. It can take like different values. So your x can be equal to 3 or 4 or 5, etc. Not just one value. So x is it's a variable, right? So this x, that's a good point, because your x is supposed to be a variable. So your data value x here, x is a variable, which means X, so X can take any, any value. Okay, so it can be equal to 3, 4, or 5, or 2. Okay, so it can be 3, 4, 4, or 5, or 2. It's a variable. Now, so that's for X. The sum. So when I say the sum, in this case, that will be the sum here. So when I write like sum of x's means just the sum of your data values. So it's like 3 plus 4 plus 5 plus 4 plus 2. And the sum of your x's, the sum of your data values, right? So this is the sum of your data values. And then there's the size of the sample. We said we denote the size of the sample by n. And in this case, we have 5 numbers. So the size of the sample n is 5, right? The size of the sample n size of the sample n is actually equal to 5 because we have 5 numbers. Because we have 5 numbers. We have 5 numbers. So all I'm saying here, guys, is the formula for the mean. Remember, we said the mean is it's just the sum of all data values over the total number of values. So we denote the formula by the formula for the mean. So it can be denoted by the formula of the sample mean. So first we said the mean, when we have a sample data, the mean is denoted by x bar, right? That's the notation for the mean when we have a sample data. So the mean x bar, so x bar is equal to, so we said it's equal to the sum of all data values, the sum of all data values. So that will be this capital sigma, this thing here, the capital sigma x, the sum of your data values. So sum of your data values divided by the size of the sample, right? The number of data values, and that's actually denoted by lowercase n, right? The lowercase n, that will be the size of the sample, so divided by n. So I mean, this is just a notation, all right? I mean, because later we're gonna use this notation for for the mean, for the size of the sample, etc. But it's clear how to apply such a formula, right? You have to take the sum of all data values divided by the size of the sample, or the number of data values. I mean, it's just another way. It's just a notation, right? It's just how we denote this formula of the mean. So this is for the sample data, but if you have like a population data, then we'll write the formula for the mean. So the formula for the population mean, the population mean, so first we said we denote the mean, the population mean by, you see here, when we have a population data, the mean is denoted by this mu, this Greek letter mu. Okay, instead of x bar, we use mu. Okay. So it's mu equal to the sum of the x's, sum of your data values, and the same thing, divided by, instead of lowercase n, we're gonna use capital N, right? For the size of the population, right? We said we're gonna denote, if you have a population data, we denote the size by the capital N, okay? So, so here we're gonna divide by capital N. And again, this is just a notation, guys. I mean,
I have a question.
yes, please.
Okay. So basically, when it's coming to the sample data and the population data, this is what will be asked in a question, so we
Yes.
know exactly
Yes.
what to look
Yes.
for. But
Yep.
it's basically the same method of the mean that
Yeah.
you showed us with adding up everything. So
Yep.
if we see a question that says the formula of the population mean, and it shows this, is basically the same thing of adding up all of the data values divided by the number of values.
Absolutely, it's the same
Okay.
formula. It's just
Different
just-
ways of implying it.
Yep.
All right,
Yep.
perfect. All right.
Yep. And I think it's, I mean, the formula, I think it's not really hard to apply, right? It takes some of the data values over the size of sample, but it's just yeah. All right.
But they will most likely give us these words, right? The formula of sample. They're not going to leave it blank, or if they leave it blank, they'll be asking us, is this a population or a sample?
Oh yeah, you're gonna
Okay.
know. Yeah, of course.
Okay, perfect.
Yeah,
All right.
it's gonna depend on the question. Yeah, absolutely. And the thing is, we're gonna use this notation later in the next like next chapters, like the X bar, the mu, you know, the N. We're gonna use that later, and the X also. The X, the variable X, which is just your data value. Yeah, we're gonna use this notation later. That's why I have to introduce it today, because we're gonna use them later. All right, so you know what? We can probably do an exercise. You know, so we have all these three different kind of average, and so let's have an exercise. So let's say we have the following sample data. I see there's this question in the chat. Oh, okay, Yanni. No problem. Okay. All right, exercise. So let's say we have the following data. Data values. Let's say sample data values. All right, let's see. Okay, so we have 4, 2, 2, 1, 3, 2, 1, 4 again, and then 7, and then 6. So we have like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right. So please try to compute or try to find. So please try to find first the mode. Find the median and find the mean. So we have, again, we have 10 numbers, right? Yes, 10 numbers. All right, give you some time to think about this exercise, guys. Of course, guys, I mean, the mean, this is like, the mean is the most common, most common form of average. I mean, mode, again, mode, median, mean, they're all like different kind of averages. And the mean is like the most common form of an average, right? I mean, that's what we use like most of the time. We use the mean to compute the average. And we'll see like after this exercise, there are like different kind of means. um, there's like the trimmed mean, there's the weighted mean. Probably I should turn off the notifications, right? I think the weather is going to be very nice this weekend. I mean, all right, guys. I guess you probably need more time. You're done, Christina? Mhm. Okay. Jessica too? Edward too? Okay, perfect. Does anyone need more time? Well, let's start with the mode, right? Any guess what will be the mode here?
2.
I
Yes,
got 2 as well.
yes, 2. Very good. So as you can see, 2 occurs like how many times? It's like 1 time, 2, 3 times. Okay, compared to, for example, 4. 4, we have 2 4s, and yeah, so yeah, the mode is 2, absolutely. So again, the mode, that's the number of data value that occurs most frequently, right? So here 2 occurred like 3 times, more than 4, 4 just 2 times, you know, and everything else is just like a 1 time, right? Oh yeah, 1 is 2 times. We have all right. Does anyone have a question how I got the 2? Please, I mean, don't be shy. Unmute yourself. I mean, I'm here to answer your questions. Okay, very good. If everyone understand how I got the 2. All right, now what about the median? Any guess?
I got 5.5.
5.5? Anyone
I
else
got it wrong.
got 5.5? Same answer?
5.5.
I got 2.
I got 2.5.
2.5. Okay, that's
Yeah, 2.5.
oh, okay. Now that's like very different answers. All right, so okay, let's do that then. Okay, so number 2. So first, step 1, we order. We need to order our data values. All right, so smallest number would be 1. We have 2 1s. So that's 1, right? 1. Then we have 3 2s, 2 4s, and then 6, and then 7, right? So that's 1, 2, 3, 4, 5, 6, 7, 8, 9. I think I forgot the number. How many numbers? 1, 2, 3, 4, 5, 6.
3.
Oh, I
You
forgot the
number
3.
3.
Yeah. Thank you. I appreciate it. So I forgot the 3 actually. And so as you can see, it's easy to make mistakes, right? I mean, even myself, I can, sometimes make mistakes. So it's all right. So that's the order. Now step 2, I need to find where's the position of the middle, right? So position of the middle, or the center, the middle, that will be, because we have 10 numbers, right? 10 numbers plus 1 over 2, that's 11 over 2, that's 5.5. So again, here, what we are saying is the position of the middle would be between the 5th and the 6th data values. So 1, this is first, second, third, fourth, 5th. So this is my 5th number, and this is my 6th number. So the middle is between 2 and 3. Okay. So then my median would be 2 plus 3 over 2. And that will be 2.5. We always divide by 2 because that's like the average. So it's 5 over 2. And so the median is 2.5. Okay. I think someone got like a 4 as answer. Anyway, so I mean, you see now, guys, why it's a 2.5. So position of the middle, you count how many numbers you have plus 1 over 2. That will give you the position of the middle. And then you need to take the numbers in the middle, take the average of the numbers in the middle, right? And again, here, the middle, it's between 2 numbers. It's not one number, the center of the middle. It's not one number. It's actually between 2 numbers.
So you
right.
did 2 plus 3 because you broke down the 5.5?
Yeah, because 5.5, it means that the middle position of the middle, it's between the 5th and the 6th data values.
Right.
Okay, this is like the 5th number, and this is the 6th number. The 5.5 is between 5 and 6.
Okay, thank you.
Mhm. Anyone else? Any question, guys, about that? I know this, sometimes this meeting is confusing. All right. No more questions. Then what about the mean? Any guess?
I got 3.2.
I got 3.2.
3.2. Yeah, I think that's the correct answer. Yes.
3.2.
So I had the median wrong and the mode right and the mean right.
That's not bad. Yeah, so the so the mean, would be, I'm gonna use the notation we have like for the sample data. You know, we said like X bar, it's the sum of the x's, sum of the data values over the size of the sample. So that will be 4 plus 2 plus 2 plus 1, 1 plus 4, 7 plus 6 over, and that's the number of data values, that's the size of the sample. Number data values. So we have 10 numbers. We have 10 numbers. So we need to divide by 10. Anyway, so 4 plus 2, 6, 8, 9, plus 3, that's 12, 14, 15, 19, 26, 32 over 10. And as you said, guys, then the mean would be 3.2. So that's 32 over 10. And so the answer is 3.2. Very good. All right. Now, next. So there's a disadvantage. There's a formula of the mean because it's the formula of the mean. It's you know, sometimes we have this exceptional values we discussed last time. You know, some exceptional values we have, like when you have like a data set or data values, and so the mean usually is actually affected by exceptional values. You know, if you have like numbers very different than the other numbers, like much higher or much lower than the other numbers, then your mean is going to be affected by those exceptional values. Okay, and so your mean, you know, the idea here is that your mean or your average is going to represent your or is going to describe your data values. So if it's affected by like some exceptional values, right, then probably we need to find like another way to compute the mean or the average, right? And so that's why we have what I call trimmed mean. So so the idea here is that so as I said, so the mean, the X bar, so sometimes is it's affected sometimes by, sometimes, not all the time, of course, but sometimes by the exceptional values, by exceptional values, or what I call outliers, right? And so this is just numbers or values, very different values, very different than the other values. Okay, so for example, I mean, if you did your homework, first homework, you can see like in the exercise number 2, you know, you have like this the salaries of your employees in a company, and there is the salary of you know, I think 200.
Yeah, I think there's like 3 values with 0, right?
Yeah, absolutely.
Mhm.
Yeah.
Yeah.
So the idea is, so that number, this the would affect your mean. So so we need to find. So in this case, we need to find like a different way to compute the mean. And to exclude, you know, you want to exclude those exceptional values because they affect your mean. So in that case, we need like a different way to compute the mean. So we want to exclude the exceptional values, right? To compute the mean. Exclude. So the idea is to exclude the exceptional values or exceptional numbers. Exceptional numbers. All right, so, and that's how we come up with this idea of a trimmed mean. So there is this trimmed mean. All right, so what's a trimmed mean? Well, it's is the mean of the data. That's the mean of the data values left after trimming like the percentage of like the smallest and the largest data values. So after trimming, the percentage of the smallest and largest data values. So this percentage is usually like 5%. So usually the percentage is 5%. So when I write, just one thing, guys, when I write 5%, this is like, this is saying this is like 5 over 100. Okay. So you see this is simple symbol here, percent, right? Percent means it just means division by 100. Okay. So when I write like, I don't know, for example, 20%, that's like 20 over 100. Okay. Or you write like 1000%, it means, you know, 1000 over 100. So the percent symbol means division by 100. Okay. Percent means division by 100. Division just mean the division by 100. Anyway, all right. So how do we find the trimmed mean? Question. So I'm going to show you the steps. How do we find the trimmed mean? Or how do we compute the trimmed mean using let's say the 5%. 5% of the data values. All right, so you have your numbers, you have your data values. First step is always to order. You need to order your data values. So step one, we need to order the data values. Okay. Step two, we need to compute. So we need to find what's 5%? I'm gonna show you how to do that, of course. What's 5% of your data values? Step 3, you need to delete the so step 3. So we need to like delete like the top and the bottom 5% of values. And then last step, we can then compute the mean of the data values left. So step 4, we're gonna compute the mean of the remaining data. So after you exclude 5% of the smallest and largest numbers, then you compute the mean of the numbers left, okay? All right, so let's do an example. I'm gonna show you the example how to apply all these steps. What time is, oh, okay, 1:25. Do we have time? Well, I need probably at least 10 minutes. You know what, guys, I'm gonna stop here. I mean, next time I will come back to this tree mean, and you know, we're gonna try to finish this section next time. All right, everyone, thank you for listening, and hopefully I'm gonna see you on Monday. And also enjoy your weekend because it's gonna be really nice. Okay.
Thank you.
Thank you.
All right,
Thank
have a
you,
good
everyone.
Sir.
Thank you.
Professor.
Have a good weekend.
If you have a few minutes, could I stay behind and ask a question?
Oh yeah. I'm gonna just stop recording.